Input and output deals with the problem of how do you get data into your program and what can you do with the results once you've processed the data. Managing input and output is a key part of most scripts. We frequently think of a program as a data pipeline, guiding from input via processing and analysis to output. If we look at the kinds of ways we can get data in, we can, for instance, accept data from a user. Input accepts a prompt as a string and returns the evaluated input from the user. So here we'll say, give me an array. We run it. We didn't leave a space or anything at the end of our prompt, so our cursor is right up against those data. So I'll give it the array 1, 4. And this returns to us an array 1, 4. You'll notice over here on the right, this is a double. It has size 1 by 2. Name is ands, which is, of course, the default name for the output of whatever the last command was. Now, the interesting thing about this, in contrast to Python, is that Python always gave you a string, and you had to process it. In distinction, MATLAB's input already parses or evaluates whatever input is received from the user. If you type in a 20, you'll get a numeric 20 back. If you type in an array, you'll get a numeric array back. Probably the most important way to pull in data inside of MATLAB is import data. This is the Swiss Army knife of file readers. It's capable of inferring the correct file type, and it returns something like an array or a cell which contains the results in a manipulable format. Its return type can be variable, though, which is a quirk of MATLAB, so you'll need to be careful in knowing what you're processing. We can open CSV files, we can open structured plain text files, we can open images in a PNG or a JPEG format and otherwise. And all of these things it'll be able to handle, but it might give us something back different in each case. Let's look at this with an image first. Here, we're going to import a picture of a rabbit riding a lion. It's stored as rabbit-bw.jpg. It's going to be stored as A. A is brought in as an input. We can see over here it's a uint. It's 236 by 236. If we double click on it, it'll open up the spreadsheet-like interface for editing this, and you can see it mostly consists of single values of 255. If we scroll around, we should be able to find other kinds of data there, zeros and fours and ones. If we want to see what this looks like, probably the easiest way is to just use image A. In this case, you can see that it's automatically rendered with the default color map, where yellow represents those 255 values and blue represents the lower values. So we're able to read this and interpret this, but it seems a bit odd because of what the default color map is. Image doesn't give you many options out of the box. We're going to see another tool later on called imshow, I-M-S-H-O-W, which does allow more options for changing the color map, and then your images will look more like what their original source was in black or white. If we want to look at something different like a CSV file, we can do that as well. Here we're going to load precipitation hourly sample CSV. When we run this, it creates a spreadsheet, and you can see that this is labeled a struct. What exactly is a struct? Well, it's a structure that contains other data inside of it. If we double click here, we can see it has two fields. One of them is named data. One of them is named text data. If we double click into text data, we can see the kinds of data that are stored inside of this sample CSV file. So here we can see rows that include things like different stations and station identifiers. And we can see values in some of these fields that contain different numbers related to what data are being stored and processed. Besides import data, there's also imread, which specifically targets opening image files. An image file can load one of several ways. You may have a two-dimensional array with x and y axes representing the location of each pixel. This is what we saw a moment ago when we opened our image file. Or it could be a 3D array with x and y axes representing the location of each pixel, and each layer of the three layers representing the red, green, and blue color components of the pixel. But MATLAB treats images as arrays representing pixel data. If we use this with a particular file, orbitplotouter.png, then we can see MATLAB render this against a plot. We can see many of the data values that we're interested in stored here. In this case, it's storing the orbits of the outer planets. So imread pulls in and parses these kinds of image-based data. Orbits, we can see over here, is a 600 by 600 uint value, like we saw earlier with the rabbit. If we were to load another image in color, in this case duck, we'll see that this shows up as a 411 by 500 by 3 uint 8. So in this case, each layer of duck describes one particular color. If we grab all of the rows and all of the columns and grab the 3rd layer, this grabs the blue components of duck, which you can see here also consist of values from 0 to 255. And this is what the duck looks like there. A medieval manuscript marginal illustration, which reads quack. We can also grab information from the internet using webread, or an older process involving URL read and text scan. The difference is that webread is like import data in that it pulls in data and it interprets the data into an appropriate MATLAB format. URL read would pull in information as text, and then you would have to use text scan to parse through it to figure out exactly how you want it to represent things. So here we're going to pull in orbits, same way we did before, and examine it. We can see the same data that we had seen locally. Now when we need to save data and load those data again, MATLAB encourages you to store these things as MAT or MAT files. We're going to accomplish that using save and load. Let's say we have an array A. We're going to save it in a file test.mat, and we're going to save that variable A. So you'll notice we pass in a string test and a string A, where A is the name of the variable that we're saving. If we clear to remove all the data from our workspace, you'll notice that A is no longer present. We can load this again using load and the reciprocal operation here. In this case, we had to reach inside of this struct to grab the actual value that we wanted. But there those data are pulled up. We're able to find them now. MAT files are the most natural way to save information when you're not through working on a process.